All right, so second section we're going to look at on logs is 7.3. First thing we look at is some special patterns that come up with logs. So it's not really anything mathematical or a calculation we have to do. It's a special pattern. And I showed you guys one in the homework. Like anytime you take the log and the base and the argument match, the answer is 1. Okay. So we're going to look at a few special patterns like that. And then we're going to look at properties to take logs and either combine them or split them. Kind of like if you had 2x plus 3x, you can write 5x, right? You can combine like terms. Well, you can do that with logs too. There's rules for combining them together. All right, so first property, this is an equation in exponential form. That's your base. That's your exponent. Even though there's a log in the exponent, it's still an exponent. And that's the thing that's on the other side. Anytime you write something that looks like this, doesn't matter what you put in those 3 boxes, that's exponential form, always. Anytime you write something that looks like this, doesn't matter what you put in those 3 boxes, that's log form. So that's the general pattern of what exponential looks like and then what log looks like. Okay? So number 1 is exponential. It fits that top pattern. And the trick, or kind of what's happening here, is the base and that base match. Okay? Don't write this part because you need to be able to read your notes. But if these 2 things match, basically what happens is those cancel out. And the answer that you're left with is whatever was sitting right there. Okay? That's what happens. So if there was a 2 there, the answer to this whole problem would be 2. The key is, though, these have to match. The A and the A. So an example we'll do in a second would be like that. 2 and 2. They match. If one of them was a 2 and one of them was a 3, no good. Okay? But as long as they match, the answer is whatever is sitting right there. Basically, they cancel out. Okay, I'm not going to go through the reason why for all of them, but for the next few, we'll take a look at the reason why. And all the reasons why for what I'm going to show you, they're already reasons you know. Like in Algebra 1, guaranteed. You already know these things. It's just written in a way you probably haven't seen before. Okay, let's look at this one. Number 2, is that a log equation or exponential? Yeah, that's log. Right? It's got the word log. It's got a base, it's got an argument, and then it's got something on the other side. Okay, pattern here. This is a log equation. The base on the log and the base inside the argument match. An example would be something like that. The base on the log and the base in the argument match. They both 0.2 in that case. If those match, what we can basically do is cancel them out. And the answer is whatever is sitting right there. Again, I wouldn't cross it out because then you won't be able to read your notes. Now, for this one, I'm going to look at why this one's true. We just said this is in log form. Okay? What's the other form we can change it into? Exponential. So let's change it into exponential. Here's my 3 things. 1, 2, 3. Those 3 things have to go in these 3 boxes when we change it. We just have to figure out which one goes where. Okay, let's start with the A right there. Alyssa, what is this A? It's my base. So when I rewrite it, it's going to go right there. Okay, so this is just the reason why it's true. That's why I'm putting it off to the side. This is the formula you really need to know. We're just looking at why it's true. All right, so we get the base. Andrew, logarithm always equals what kind of number? Exponent. Always equals the exponent. There's your exponent. Okay, and the only thing we haven't used is the argument. And that ends up by itself on the other side. A to the r equals a to the r. Is that true? Yeah. all that rule 2 is saying is basically something equals itself. Of course, 5 equals 5, 6 equals 6. You've seen that property before. It's just saying that something equals itself. This is how you would write it in Algebra 1. You might write like 2 equals 2 or something like that. This is how you can write that same idea as a logarithm. But it means exactly the same thing. I'm not going to cross these out so you can read them. All right, so that's rule 2. Rule 3. It says that if you take the logarithm of 1, doesn't matter what the base is, the answer is always 0. Okay, so again, it's just a special pattern that comes up. Now the base can't be negative. Okay? We don't take logarithms with a negative base, and we don't take the log of negative numbers. Both of these two things always have to be positive. If you start getting into logs with negative bases or negative arguments, now you're getting into imaginaries with logs. Probably don't want to do. So, log base anything of 1 always equals 0. Right? So Courtney, when I look at that one, is that a log equation or exponential? Log. Yeah, it's definitely log. It looks just like this one. It's got the 3 boxes. Okay, so let's identify what's what. Let's rewrite it. And then the reason why this is true will be very, very, very clear. Cal, what's my base here? A. Okay. And Anthony, logarithms always equal what kind of number? Exponent, yeah. So logarithm always equals the exponent. So what's my exponent in this case?
0.
0, right? That's what it equals. Logarithm equals 0. Okay. And then Justin, the only thing I haven't used, what do we call that 1 again? It's the argument, and the argument always ends up alone on the other side by itself. Okay. So rule 3, if you rewrite it without the word log, is basically just saying if you take anything and raise it to the 0 power, the answer is 1. Yeah, of course, that's an Algebra 1 rule. Anything to the 0 power equals 1. So probably the way you've seen it way back in Algebra 1. Same rule written with a logarithm. Same idea. Okay, and the fourth one, you guys already saw this one in the homework. You didn't know this shortcut. We just had to do it out kind of a long way, but now we know a shortcut. If you take the log and the base and the argument match, the answer is always 1. I think in the homework it was log base 8 of 8. Okay, let's rewrite that one, and then we can see why that one's true. Again, this will be something else that you already know. Megan, what's my base here? Yep, my base is that one. My base is A. Riley, what kind of number does the logarithm always equal? Yep, logarithm equals the exponent. We got that. And the only thing left is the argument, and that ends up by itself on the other side. So, rule 4, basically saying if you take anything and raise it to the first power, it doesn't change it. Anything to the first power stays the same. Of course. Anything to the first is itself. So rewriting these rules makes it very clear why they're true, but when you just look at the rule itself, you might not know at first. But it's all based on very, very simple things from Algebra 1. All right, so these are just special patterns to look for. All right, let's try a couple examples. All right, so first thing that we want to do is kind of figure out which property it is, 1 through 4, and then use one of those properties to simplify it. So Abigail, if you look at example 1a, which property does that one look similar to?
Exponential.
1, 2, 3, or 4.
Oh.
Yeah, it is property 1, and it is an exponential equation. So it looks like property 1. Now, using property 1, what should the answer be? Pi. In this case, a is 2, m is equal to pi. So these cancel out, and all you're left with is that. Now, we don't even know how to type that into a calculator because you don't know how to type in a base 2 log. You don't need to know how to type it in because it's a special pattern. And that's it. Let's try this one. Log base 0.2 of 0.2 to the negative 4. Alex, which property does that one look like? 1 through 4. Yep, that's property 2. Based on the log and the base inside the argument match. So based on property 2, what should that come out to? Yeah, comes out to negative 4. Alright, let's take a look at this one. ln of e to the kt. That's a little tricky. Did anybody see what property that one is? You have to do something here that we did when we were going over the homework. Yep. It is property 2. Can someone tell me what I could rewrite to make it clear that that's property 2? What do I have to change? And then it becomes really obvious. Yep.
The ln.
Yeah. How can you rewrite the ln?
The log base of e.
Yep. Log base of e. So the circled part I just rewrote. Now copy down the rest of it. E to the kt. The base on the log and the base on the argument match. It's just like example 1b now. So Stephen, using property 2, what's log base e of e to the kt?
That should equal e.
Nope, not going to equal e. Equal e. Riley, can you help me out?
Should equal the kt.
It should equal k times t, right? These match. Right here, the answer is what's right there. So in this case, it's k times t, whatever k times t is. All right, let's see, we didn't do one of those. Let's do log base 6 of 1. Jason, what's log base 6 of 1?
It's property 3.
Property 3, which means the answer comes out to 0. Yep. Right, and let's see, we'll do one more. Log base 12 of 12. Emily, what would log base 12 of 12 be?
1.
1. That's property 4. So again, there's really no arithmetic or anything you're doing. It's just a pattern you're looking for, and then you match it up with the rule and go from there. Okay. Questions on those? Okay. All right. So next thing we're going to look at is some properties we can use to combine and separate logs. Okay? And there's three properties. So, like if you had something like that, that's one that's been combined that we can split. Here's one that's been split that we can combine. Okay, so we'll practice doing it each way. Okay, first property. It says log base A. So in other words, the base here doesn't matter. These properties work for any base. Okay. Log base A of a product, m times n. You can take that and you can split it into 2 logs as a sum. Or you could take 2 logs that are a sum and combine them into a product. You can use this equation either way. What's important is that when you split it, the base that you started with is exactly the same as the base that you end with. The base stays the same all the way through the problem. The first argument to your log is the first thing you are multiplying. The second argument to your log is the second factor, the second thing you are multiplying. So I'm not going to do this for every problem, but there's an example with actual numbers. So the easiest way I can show you that that's true on a calculator is I'll do it with base 10, because I have a button for base 10 on the calculator. So if I type in log, and yeah, I could just do 20, but whatever. So log of 4 times 5. Now if I take log 4 plus log 5, I get exactly the same thing. Okay. What are two other numbers that multiply to give you 20, besides 4 and 5? 2 and 10. So you could also take the log of 2 plus the log of 10. Same thing. You can do 40 and a half, do 80 and a quarter. I mean, you can do as many different things as you want. But the idea is that a product splits as a sum. So if a product splits as a sum, what do you think a quotient will split as? Yep. Yep, it's going to split as subtraction. And it is important about the order. Adding, it's not important, but subtraction it is. It's log of the top minus log of the bottom. Base stays exactly the same all the way through the problem. And I'm not going to type this one in, but if you wanted to check it with numbers, that's an example. And the log of 4/5 equals log 4 minus log 5. Any questions on rule 2? All right, so rule 3. Let's look at it. I want to show you something first, and then I think you'll see what the pattern is for rule 3. Let's say you had log of y cubed. What does y cubed mean? Like if you had to explain that to somebody that doesn't understand what it means to put a number up higher on something, how could you write that a different way? Yeah.
Y times y.
Hey, it's log of y times y times y. Now, we just said in rule 1 that if you have a product, I only did it for 2 things, but you can do it for 3 or 4, however many you're multiplying. When you take a product and split it, it splits as a what? A sum. And what happens to the base when you split it? Compared to the original base. Okay. What happens to the base? So look at rule 1, look at the base on the left of the equal sign. Look at the base on the right of the equal sign. And tell me how the bases compare.
You can distribute it out.
Yeah, so well, if you were to compare the two bases, you'd say that they're the same. Right? The base stays the same when you split it. So let's do that here and see what happens. We just said a product is going to split as a sum. This time it's going to be a sum of 3 things. The first one is the log of my first argument. What's the second one going to be? Same thing, log of the second argument, and the same thing again. Now, log y plus log y plus log y. Well, let's just pretend it was like y plus y plus y. What does that simplify to? Log y plus y plus y. 3 times what you were adding. Well, log y plus log y plus log y. 3 times what you were adding. 3 log y. Now, look at the final answer, and look at what you started with, And anybody see a shortcut from how you can get to the top box to the bottom box? Yeah.
Just move the exponent to the front.
You're allowed to just take exponents and move them in front. It might not be obvious when I just write that down as a rule. Like you can just take exponents and put them in front. But I showed you an example to try to explain why you can. Anytime you have an exponent on a log, you can move it in front. And where that will come in handy is when we have variables in the exponent. Because we don't like variables in the exponent. It complicates things. Well, now we have a way to get the variable out of the exponent. We can just throw it in the front, and it's not an exponent anymore. So we're going to use that idea tomorrow to help us.
What if there's already something in front of the log?
So if you already had something in front of the log, like you had like 2 log x cubed, you would have something else in front, like that. That's gone. You'd have that 6 log x. Yep. And there's another example with numbers. Log base 10 of 3 to the 5th. You can just take the 5, throw it in front. Now, that rule is going to come up when we do something from algebra with a square root. There's another way to write a square root. Does anybody remember what power is the same as a square root? Yep. That's the opposite of it. So square and square root are opposites. They cancel out. But there's a way like if I didn't have a square root button on my calculator and I wanted to know this, like the square root of 15, there's another way I can type that in. I can raise it to a certain power and I'll get the same answer. Yep. Yes, 1/2. If you raise something to the 1/2 power, it's exactly the same as taking a square root. And the reason that's important is because if they give you a problem like this, and they said rewrite that so it doesn't have any exponents, you might look at that and say, oh, it doesn't have any exponents. Yes, it does. The 1/2 is hidden in the square root, just like ln hides a base of e. There's really a 1/2 there. So if you had a problem like that and they said to rewrite without exponents, I'd be looking for this. That's how you rewrite it without exponents. And that's something that usually trips people up on the test because they look, they just see the square root, and they say, oh, there's already no exponents. Yes, there is. That's hiding an exponent of 1/2. Now, you can do that with all kinds of roots. A cube root is 1/3. A 4th root is 1/4. 5th root is 1/5. We're just going to have to worry about square roots being 1/2. Okay. Okay, so directions here. It says take the logarithm, and basically we're going to break it up into a sum or difference. That's rule 1 and rule 2. Which rule you use depends on what you have inside, multiplication or division. And it says to express powers as factors. What that means is put exponents in front. Okay? Don't leave exponents in the final answer. Put them in front as multiplication. When you multiply, that's a factor. Okay, so move it in front. Okay, so let's start with this one. Brandon, log base 4 of 3x. Is that going to split as a sum or difference? Yep, it's going to be a sum. So we're going to have a sum of 2 logs. Madison, what's going to be the base on each log?
4.
It's going to stay exactly the same as the original. Base 4, base 4. Hey, Emily, my first argument is going to be
It's going to be 3x.
okay, so if you use it all up here,
It's going to be 3.
yeah, it's basically the same thing. So log, first argument is just 3, second argument is the x. And that's the final answer. So when they say to rewrite a log, usually it doesn't mean you're trying to find an answer. You're not going to get like x equals 6. You're going to get something like that. Okay. Any questions on that? All right. Let's try this one. Log base 2 of 5r cubed. Yashira, when we split that one, is that going to be a sum or difference? Yeah. It's still something times something. Yeah, the other something is a little more complicated because it has an exponent this time. But we'll deal with that in a second step. Or if you're fine, you can do it all in one step. It's up to you. So it's going to split as 2 logs. Alyssa, what's going to be the base on each log? 2. Andrew, my first argument? 5. And Brianna, my second argument? A little bit more. It would be r to the third. But because of the directions, Sebastian, what do we have to do with that 3?
Don't we have to put it in front of the log?
We have to put it in front. If you left it as r cubed, that's not doing what the directions said. It said we'll put the powers in front. Factor means make it multiplication. And now it is. Okay. Any question on that? All right, so we did a couple with a sum. Let's look at this one. Log base 9 of x over 2. Courtney, how is that one going to split? As a sum or difference? Yes, because we have division, it's going to be a difference this time. Log, log. Anthony, what's going to be the base on each log?
9.
9 stays the same. 9. Justin, my first argument. X. And Emily, second argument. 2. And that's it. Log base 9, x minus log base 9, 2. Questions on that? All right. So we did it with a base 4. We did it with a base 2. We did it with a base 9. What base am I using here, but it's kind of hidden? Yeah. Not base 1. The ln is hiding a base of e. Now, you don't have to write log base e. Don't write it the long way. Use ln, use the abbreviation, but just keep in mind that's what you're doing. It's base e, right? Even though you're never going to be writing an e in this whole problem. Okay. Anyone think they can give me the whole thing? Final answer. Andrew?
3 times log e to the power of y.
And what's the abbreviation? We're just going to use that for log base e.
Ln
So 3 ln
to the power of y.
So what do you call this thing right here that you're going to put there?
Y.
Yeah, that's your argument, and that's not a power. Just it's just an argument to the ln function. So 3 ln y. Yep.
Minus ln 8.
Yep. And remember, that does not mean ln times 8. That'd be like saying square root times 5. You can't do that. You've got to have something to plug in there. So this is just what you're plugging in right there. 8 is being plugged into the ln function. All right, and that's your answer. Any question on that one? All right, let's try this one. Okay, so we've done addition, we've done subtraction. This one's got a little bit of both. I see multiplication in the bottom, right? Something times something. This problem, to me, when I look at it, this is pretty much what I see. That's how I break it down in my head. I say, okay, I've got something in the top, and then I'm dividing, and I've got something times something in the bottom. Yep, those somethings are a little more complicated. I'm going to have to deal with them. But for now, that's what I'm thinking. So when I split this up, deal with the division first. Deal with the division first. So Abigail, when I have division, how does division split? So when you have a log and you have something divided by something, parentheses, and you split it into two things, it's either going to be addition or subtraction. Let's try the other one. Subtraction. Okay, so anytime you divide, like, when you have something divided by something, it splits as subtraction. Okay, multiplication is addition. All right. So first thing I'm going to do is just deal with the division. So when you do it and split it, it's log of the top minus log of the bottom. Don't worry about doing anything else out yet. So log of the top minus log of the bottom. Now, I'm putting the x cubed and x plus 1 to the fourth in parentheses because all of that is the argument. The whole bottom. Right? All of that is being plugged into the log function. We still have a little more work we can do there, but for now, that's good. So that's the first step. So what we're trying to do is just break it down into simpler problems. Now, there is no rule for adding in a log function. We have a rule when you're multiplying and a rule when you're dividing. So there's nothing you can do with addition in a log. But there is something else I can do in this first part. What do I have to do in that first part? Yep.
X squared plus 1 times half.
X squared plus 1. And what's the 1/2 again?
The alternate version.
But the 1/2 is your what? It's your exponent. Yeah. So x squared plus 1 all to the 1/2. And where's that 1/2 going to end up going? Go.
In front of the log.
In front. So this should be written like this. The x squared plus 1 is all the argument. Both of those things. Because they were all together under the square root. So when you get rid of the square root, you still have to explain they're all together. It's still together. It's just now you put the 1/2 in front. So the first part, we're done. All right. Second part, we're going to subtract something. This can now be split. We have multiplication inside the argument. When I look at the second one, this is pretty much what I see. It's something times something. That's how I look at it. When you have something times something, that splits as what? Yeah.
Something plus something.
Right, something plus something. So I'm going to split it up. But I have to remember, however I split it, I'm subtracting this whole thing. Doesn't matter if you split it into 20 things, you're still subtracting the whole thing. That's why I put brackets. Because I got to subtract that whole thing. So it's log base A, log base A. First argument is x cubed. Second argument is the second thing, x plus 1 to the fourth. Now, if you didn't put brackets there, it would be kind of like writing something like this. There's a difference between that and that. In the first case, the negative is applying to the whole thing. It's like a distributive. In the second case, the negative is just applying to the 3. But you're subtracting that whole log. However you want to rewrite it, you can. But you're still subtracting all of it, not just part of it. Okay? That's why there's brackets. Okay, first one's good. if I was doing this problem, I probably would be combining some of these steps so I didn't have to keep rewriting it every time. But if I write it all out, you can look back and kind of see every single step. All right. What do we have to do a couple times in the second part in the brackets? Remember what the directions said, yeah? Right. Do not leave exponents where they are. It said put them as factors, which means put them in front. So 3 log base ax plus 4 log base a. Now you've taken out the 4, but you still got to leave the parentheses around the x plus 1. Okay? So we understand that those are grouped together. And that's pretty much how you would see a final answer. I mean, the only thing the book could do is they could distribute the negative in, say, minus 3 log base ax minus 4 log base ax plus 1. You could. That's not wrong. But I'm going to leave it at that step. Okay, so as far as splitting logs, that's as bad as it can get. It's the hardest kind of problem you could have to split. Now, when we're taking logs and splitting them apart, I think that's more complicated because you already started with something that was together, nice and compact. And at each step, you're making it bigger and bigger and bigger. Well, now we're going to reverse that. We're going to start with something that's not compact, and at each step, it's going to get simpler. Right? It's going to all go back together. So I think doing it this way is easier. So directions say combine the following into a single logarithm. So just think of every step you would have done, but now do them in reverse. So anyone think they could tell me what the first thing you would do here is? And if you get stuck, think about what the last thing you would have done to get that answer would have been, and reverse that. Yeah? Put the 4 back as an exponent. Yep. So log base A7 plus log base A of 3 to the 4th. Now, if when you do that, you've got some arithmetic you can do, you should just take care of that. Okay? 3 to the 4th power, we can simplify. And what is, what's 3 to the 4th power? 81. Okay, so now we have a sum of 2 logs. We can combine that into a single log. When you have a sum, how does it recombine? Yeah.
Since it's addition, it'd be multiplication.
It'd be multiplication. 7 times 81, which is 567. So log base A, 567. And there's your answer, all combined back together. Once you combine it like that, there's really no way to split it again, because it's kind of like if I said to you, all right, I've got the number 20. How did I get that? Well, all kinds of ways you can get the number 20. Maybe I did 19 plus 1. Maybe I did 10 times 2. You don't know. Once you combine it all together, you can't really go backwards to what you started with. Right? Okay. Questions on that one? All right. So that's that. Let's try this one. Log 2 log base 3u minus log base 3v. Let's see if we can do it all in one step. When I combine that all into a single log, Stephen, what's going to be the base on my log?
It would be 3.
Yeah, it's going to be a base 3 log. Now, anyone think they can tell me my argument? What is going to go inside the parentheses? Yep.
You just like that.
Okay.
Oh, over b to the third.
Well, it would be v to the third if you had something like that. But we don't have a 3 to put back as an exponent there. So it would be u squared over
Squared over b.
u squared over v. Yes. There is no exponent in front of that other log to put back. You've already taken care of this 3 as the base. That's right there. So log base 3, u squared over v. Now, in the homework, you might see something where they write this in the book. They may say like u squared is greater than 0 and v is greater than 0. Don't let that confuse you. It's just basically saying u and v are not negative numbers. Because if they were, you'd get an imaginary answer. Right? So that part's not really important, but it throws people off when they see it. Don't worry about it. Any questions on that one? All right, let's jump to this one. So at first, when you look at it, it's like, whoa, a lot of stuff. We're going to be able to do this all in one step. Okay. When I look at it, I try not to look at all the individual things. What I try to look at is this: something plus something plus something minus something. That's what I look at. I look at the pattern. When I combine this into a single log, Andrew, what's my base going to be?
Your base is going to be A.
My base is going to be A. Now, the first 3 are addition. How do you combine addition? What does it turn into? Yeah, multiplication. This times that. So the way I'm going to write it is 9 times x times x squared plus 1. Here's the first 3. 9 times x squared plus 1. I didn't want to write x9 because we normally put the number in front, 9x. The last one is a subtraction. When you combine logarithms, what does subtraction turn into? Division. Divided by 5. And that's your answer. Only thing you might see on that one is they could distribute the 9x. If they did that, it would be 9x cubed plus 9x over 5. So 9x times x squared is 9x cubed. 9x times 1 is 9x. If it was a short answer question, I would accept either one. If it was multiple choice, maybe you would see either answer. You just have to understand these 2 answers are the same. So if you get the top one, but they list the bottom one as a choice, well, you just have to know that your answer matches the bottom. Any question on that? All right, so we looked at the special properties. That was the first thing. Second thing was the properties that we use to either combine logs or separate them. And the last thing is the change of base formula. And what this allows us to do is type in logs that are not base 10 or all right, so basically the first time we're going to figure out, we're going to see what the change of base formula is, and then you're going to see a pattern, and then we'll kind of generalize that into a rule we can use all the time. All right, so basically we've got an expression, and it's starting off equal to y. The problem is a could be anything you want. We don't know what a is. If it's a 10, we're fine. If it's an e, we're fine. If it's something besides a 10 or an e, we're stuck. We don't know how to type it in. So, when I'm done, I want to have a formula for y again, because I want to know what y is. That's the goal. I just don't know how to type this in on the calculator. I want a different way to type this in. But I still want to get it equal to y again when I'm done. Okay? Just going to look a little different. So, Sebastian, is that equation in log form or exponential?
Log.
That's log. So let's change it to exponential. Brianna, what's my base? A. Courtney, logarithm always equals what kind of number? There's your exponent. And then argument ends up alone on the other side. Okay, so that's the first step. Okay, second step. Remember, I want y by itself. Well, now I've just messed that up. By writing it in exponential, y isn't by itself anymore. So now I'm going to get y by itself again. The problem is y is an exponent. I don't want the y as an exponent. So you're allowed to take exponents and just put them in front, but you have to have what in your equation in order to just move exponents to the front? You got to have logs in your equation. So, just like if you had this, you are allowed to use the square root function as long as you do it on both sides. Square root, that's fine. Well, you are allowed to use any function as long as you do it on both sides. So, let's do that here. Let's log what's on the left, and then we're going to log what is on the right. So that's just a little trick that's going to allow us to put the y in front. Now, when I said take log of both sides, I didn't put a base. So what base am I assuming if it's not written? 10. And that's good because we have a button for base 10. So let's see where we're going to go. Now, the y can go in front. So y times log a equals log x. Right. And now we're one step away from getting y by itself again. When I look at that, I see this. Y times something equals something. How do you get a variable by itself if it's multiplied by something? Yeah. So what would you divide both sides by to get y by itself here?
Log.
Yep. Log a. Log a. That's gone. Log a. Now you have y by itself again. It's exactly what you started with. But you don't have the same formula. You have a different way to find y. Log x divided by log a. And since there's no base there, we're assuming base 10, which is something you can type in on the calculator. So look at this, and look at that. If I had, let's say, log base 2 of 6, it fits the pattern in the first box. I don't know how to type that in on the calculator. That's a base 2. Anyone think they could tell me how to rewrite log base 2 of 6 so it is something we can type in? When we rewrite it, we're going to have a fraction, just like this. Andrew?
Log 6 divided by log 2.
Exactly. Log 6 divided by log 2. So the pattern is log of the argument divided by log of the base. That's how you type something in. That's not base 10 or base 8. It's exactly what we just wrote. Log of the argument divided by log of the base. Now, I also wrote another way to do it. I wrote ln. Well, you can use ln as well. Right? It would come out exactly the same. So log base 2 of 6. Let me show you. Log 6 divided by log 2. Let's type it in. Log 6, close parenthesis, divided by log 2. Now, type the same thing with ln. ln 6 divided by ln 2. Exact same answer. So I would pick one of the two ways to remember because they're the same. Doesn't matter which one you use. Unless your calculator doesn't have one of these buttons on it, then you got to use one or the other. But if you're using a scientific calculator, they should have both buttons. And that's called the change of base formula. Either version. Okay, so we'll just finish up finding a couple logs that are a base that's not 10 or e. All right. How about Abigail? What's my base on A?
5.
5. Do I have a button for base 5 on the calculator? No. I have a button for base 10. I have a button for base E. So you need to rewrite that to type it in. Emily, can you tell me how I would rewrite that? You have two ways. I don't care which one you pick. So I can type it in. Yep. And this is one that you usually plug in. And there are going to be some of those on the test. So you do need a calculator to be able to do that. Log 12 divided by log 5. So it's about 1.54. That's it. So not very hard to type in a base besides 10 or 8. As long as you know this little formula. And example B. Megan, how would I rewrite that so I can type it in?
Log 16 or log 8.
And if you want to check it with ln, I showed you guys once, you get the same answer, but you can do it if you want. Log 16 divided by log 3. Doesn't really matter if you close the parenthesis there because you're done typing. If you don't close it after the 16, it will come out wrong. About 2.52. Okay, and that's how you type in logs that are not base 10 or base. Any questions on that? All right. Okay, so homework tonight is on 485. It's 7 to 15 odd, 31 to 33 all. And then it skips around a little bit. 39, 40, 51, 52, and 65 to 69, just the odds. Don't forget, I will be after school today. I know we had to move the day of the test, but I can't move my extra help. So I will be after school today. If you need anything or have any questions. Otherwise, if I don't see you, we'll go over that first thing tomorrow.